Hello students. In this video we're going to answer the following question related to continuity here. So we need to find these parameters A and B, and this is a piecewise function, so we need to find the parameters that A and B that make this function continuous. Now if you first look at this function, the first branch of this function here, you have 2 over x, okay? So we have hyperbola, and then the same thing on the bottom, we have a 4 over x, so we have a hyperbola, and then in the middle we have a line. So we have to somehow connect all these curves together. So we're going to look for something like this. Okay, so the first branch, for this thing to be continuous, here's our hyperbola sloping downward, we would need to connect with the line here at this point, and at this point here is -1. And then similarly, as this line goes up, we need to connect with this hyperbola here at, and this is the point 1/2 up here, okay? So really the strategy for this problem is to determine where the left-hand limit equals the right-hand limit, and we want that to be at -1, and then we want those, we want to find out what are the values for A and B, the slope and y-intercept that get this line to connect these two hyperbola branches. Okay, and then similarly we're going to look at the left-hand limit, and that'll be this line here, and we want that to be equal to the right-hand limit for this hyperbola branch here. So anyways, here are the cases. If I write this out mathematically, I'll have the limit as x approaches -1 from the left, so that'll be as we're approaching -1 from the left, and so this f of x will be this branch, and then we want that to be equal to the limit as x approaches -1 from the right, and that'll be this branch here, so that'll be this hyperbola, and we want the line to match up with the hyperbola. And then similarly, x approaches 1/2 from the right, from the left, that'll be this line here, and then x approaches 1/2 from the right, that'll be this hyperbola here. And this is what it'll look like. So I'll just fill in f of x, and that's going to be this branch. This is when x is less than -1. That's this case here. And then when x is greater than -1, that'll be this case here. And then similarly, when x is approaching 1/2 from the left, that'll be x is less than 1/2, that'll be this case here, and that's this function here. And then when x is greater than 1/2, that'll be 4 over x, and that'll be this case here. So one thing I'll point out is I converted the 2x to the -1 power, and I made that 2 over x, and 4x to the -1 power, and made 4 over x. Okay, so now I have to solve 2 equations in 2 unknowns, okay? So here are the 2 cases I have to consider. So what I do now is I take x, and I say x is approaching -1 from the left. Well, since -1 is in the domain of this function, and this function here is continuous at -1, I can just plug -1 in, and I get -2. Similarly, since ax plus b is continuous at -1, I can plug -1 into this function here, a times -1 plus b, and that just simplifies to -a plus b. So I get this linear equation. Similarly, I plug 1/2 into ax plus b, and I get a times 1/2 plus b, and then I get 4 divided by 1/2. And here I made a little cloud thought. 4 divided by 1/2 is the same as 4 times 2, and that's 8. Or you could think of it as how many times does 1/2 go into 4, and that is 8 times. So I have 1/2 times a plus b equals 8. So now I have to solve these 2 linear equations, and notice that there are 2 unknowns, and we're used to solving, at this point, hopefully if you're in calculus, you know how to solve systems of equations. So I will just quickly. So I'm cleaning this up a little bit. So this is where we left off, and then I set up these 2 equations. What I did here is I took the -2 and I moved it over to the right, so I have -a plus b equals -2. So I just switched the order here, and then I have 1/2 a plus b equals 8. So I have that equation here. Now what I'm going to do here is I'm going to multiply the top equation by -1, and when I do that, this a will become a positive a. I'll have a minus b, and I'll have a plus 2. Now the reason I did that is because when I add these 2 equations together, I want these b's to cancel. And when I add these together, I have a 1 here in front of this a, and I add that to 1/2, and I get 3/2 a, and then 2 plus 8 is 10. Okay. Then I'm just going to take this 3/2, and actually I'm going to multiply this by 2/3, and I'll multiply this side by 2/3, and I'll get the cancellation here, so I'll just get a coefficient of 1 in front of the a, and then 10 times 2/3 is 20/3. Now that I have the parameter a, I can go back to, let's say, this equation up here, and I can push the a over to the other side, so I'll have minus 2 plus a, and that solves for b, and then I just take my a value, 20/3, and I add it in here, so I have minus 2 plus 20/3. Now, minus 2 is the same as minus 6/3 if I want a common denominator, and then that'll give me 14/3. What I have here is when I solve the equation, when I solve those two linear equations, I get a is 20/3 and b is 14/3, and that means I found the parameters that make the equation of this line here, so that it connects with this point and this point, and now this function is continuous over the whole real line. All right, good luck.